Good evening, ma'am.
Very good evening. Good evening, everyone.
Good evening, ma'am.
I'll wait for just 1-2 minutes more.
Hello, ma'am.
Good evening, Beta. There is somebody with the name Fitness. Please change your name. Okay, I think changed. Is there anybody who is attending the session for the first time? Anyone in the class who is attending for the first time? Because I can see all the names which were there in the previous 2 classes as well. If there is anyone who is joining for the first time, please let me know so that I can repeat whatever the topics are to be repeated. Else you will be getting the recordings.
Excuse me, ma'am. I missed the last class.
Okay. Okay. Okay, let's start. It's already 8:35. So let's start. Okay. So last time I told you about the forces which are present in nature. Okay. Forces which are present in nature. So the type of the forces which are present in nature are, the first type of the forces your gravitational. The first type of the force is your gravitational force. Okay. Second type of the force which we are having, which we observe in the nature, is your electromagnetic force. Okay. Electromagnetic force. The third type of the force which we are having is your strong nuclear force. Okay. Strong nuclear force. And the fourth type of the force which we are having is your weak nuclear force. Okay, is your weak nuclear force. Right. So last time we discussed about your first type of the force, that was your gravitational force. Okay. Last time we discussed about the type of the force which is known as your gravitational force. So I already told you that gravitational force was given by Isaac Newton. Okay. It was given by Isaac Newton, who observed that every body in this universe attracts every other body. Okay. Every body in this universe attracts every other body with a force which is known as gravitational force. Okay, every body in this universe is attracting every other body with a force that is known as your gravitational force. Okay, now what Newton said that the force of attraction between every pair of the particles or the bodies. Suppose I am having two bodies. Okay, let us suppose that the first body is A and the second body is B. Okay, we are supposing that the mass of the first body is m1 and the mass of the second body is m2. These two bodies are separated by a particular distance. Let us suppose that the distance in between these two bodies is small r. Okay, we are assuming that we are having two bodies. The first body is body A, which is placed at the position A, and the second body is placed at the position B. Okay, these two bodies are having masses m1 and m2 respectively, and we are having the distance of the separation in between these two bodies as small r. Okay, what we have now, we have that according to Newton's law of gravitation, according to Newton's law of gravitation, what it says that the force, because we are studying here the forces in nature, so we will be calculating the force only. So the force is directly proportional to the product of the masses, that means the product of M1 and the product of M2. Okay, that the force is directly proportional to the product of the masses of the two bodies. Okay, and force is inversely proportional to the square of the distance in between the two bodies. Okay, suppose I'm supposing that the two bodies are there and these two bodies are kept at a distance of small r. So what I say over here, according to Newton's law of gravitation, we have that the force is directly proportional to the product of the masses of the two bodies. That means the product of M1 and M2, and force is inversely proportional to the square of the distance between them. If the distance is small r, that means it will be equivalent, it will be proportional to the square of the distance. That means it is proportional to r square. Okay, now because on the left hand side in both the equations, I have force only. Okay, so when I am combining up these two equations, what it becomes? It becomes F is directly proportional to M1, M2. Okay, and in denominator, we will be having r square, because what we have over here, we will be having in the denominator as r square, because r is the distance. Okay, so we have the equation as F is directly proportional to M1, M2 upon r square. Okay. Beta, you have entered with the name Superboy. Please rename yourself. Okay, so that comes out to be your F is directly proportional to M1, M2 upon R square, right? So now when we are removing up the proportionality sign, so what we have over here, when we are removing up the proportionality sign, so always a constant is added over here. Okay, in this case, the constant will be F is equals to G into M1, M2 upon R square. What is G here? G is called as universal gravitational constant. Okay, universal gravitational constant. Right. Now, beta, you will be having one confusion over here, that sometimes we are writing capital G and other time we are writing small g. So small g is totally different from capital G. Capital G is universal gravitational constant Okay, and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, so when we are using this value, so that comes out to be for your universal gravitational constant. Okay, that comes out to be for your universal gravitational constant. But in other case, when we are using up your value small g, we are not using it over here, but I'm telling you the difference in between the two. Okay, so when we are using up your small g, so what is small g? Small g is acceleration due to gravity. Okay, small g is acceleration due to gravity. Clear? That is acceleration due to gravity, right? So it is measured in, because acceleration, this is acceleration, so it is measured in the terms of meter per second square. Okay, and its value is 9.8 meter per second square. We are having up a derivation, the relation between capital G and small g. Okay, so we will be doing that with the time, but here it is important for you to know that we are having two terms. One of the term is capital G and the other term is small g. Okay, your term capital G is universal gravitational constant and your term small g is acceleration due to gravity. The value of capital G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, and when we are calculating up the value for your small g, in that case, we are having up the value as 9.8 meter per second square, because your small g is acceleration due to gravity. Okay, so the unit for acceleration is meter per second square. Am I clear till here? Any
Yes,
doubt,
ma'am.
anyone?
No, ma'am.
Any doubt, anyone? Just go through once whatever is written on the screen. You can ask me if any doubt is there. Either you can write in the chat box or you can raise your hand. You can unmute yourself and ask me. The small g is, you people are already using the small g. You have already done the numericals till 10th standard. Hai na? Sometimes it was given in the question that u small g is equal to 10 meter per second square. If it was not given, you were using this value as 9.8 only, right?
yes, ma'am.
Yes, ma'am.
There is a relation between capital G and small g. अभी आएगा बेटा वो आगे तो करवाऊंगी मैं आपको. But till here, it is important for you to understand that there is a difference in between capital G and small g. It's not up to your wish कि आप कहीं पे capital G लिख रहे हैं, small g लिख रहे हैं. No, because all these notations are scientific notations, right? These are already proved by scientists. We can't change them according to our will wish, right? No doubt.
No, ma'am.
Okay, let's move further then. Now, suppose I told you that it is the force of attraction. Okay, it is the force of attraction. So let us suppose that I am having up a body A and other body B. Right, this body is having mass m1 and this body is having mass m2. Okay, now what happens over here? Let us suppose See, beta, when the gravitational forces between the two bodies are acting now, we are considering them as equal. Okay. Let us suppose that we are having the force F12. Force F12 is the gravitational force on A due to B. Okay. The gravitational force on A due to B. Okay. And when we are taking up your force F21, so that becomes the force on B due to A. Okay. See, beta, this is F12. F12 means which is acting on first body due to second body. Okay. Which is acting on first body due to second body. So first body is your body A. Okay. So the force which is acting on body A due to body B, and F21 is the force which is acting on body B due to body A. Okay. Now, when these two forces are acting, so the force from here will be your F12. Okay. Because this is your body 1. So force which is acting on body 1 due to body 2 is F12. And from here, we have F21, that is the force on second body due to first body, right? So what this gravitational law says, it says that the action and reaction are equal and opposite to each other. Okay, that means action is always equal to minus of reaction. That means the force F12 is equal in magnitude, right? But that is opposite in direction. Okay, action is equal to minus of reaction. Both the forces are equal in magnitude, but both of them are acting in opposite direction. Am I clear?
Yes, ma'am.
Okay, so now comes the examples of your gravitational force. So what are the examples? The first and the foremost example is the gravitational force keep the earth or any of the planet in the solar system in its orbit around the sun. Okay, right. I'm repeating, the gravitational force keeps the earth or any other planet of the solar system in its orbit around the sun. Okay. The second example, see beta, we live on the surface of the earth. Okay. Why we are able to live on the surface of the earth? Because of the gravitational force between the earth and us. Okay, we are able to live on the surface of the earth because of the gravitational force which is acting between the earth and us. Right. Next example, the moon is orbiting around the earth. Okay, due to the gravitational force between the moon and the earth. Right. Now, if there is gravitational force in between the moon and the earth, so which phenomena is taking place because of that? You have studied this in geography also. There is a phenomena which is taking place because of the gravitational pull between the moon and the earth. What is that phenomena?
Law of attraction.
There is something happening time to time. Yes, very good. Avnish, very good. Okay, very good. I'm answering you, Ayush, 1 second. So this is the thing which is acting over here, tides. Okay, tides which are present in the ocean, they occur because of the gravitational force between the moon and the ocean water. Okay, tides of the ocean occur due to the gravitational force between the moon and the ocean water. Okay, now the next thing, see beta, after every few days, the scientists are launching satellites. Okay, those artificial satellites, why they move around the earth? They are able to move around the earth because of gravitational force only. Okay, the gravitational force between the earth and the artificial satellite, which keeps the satellite to move around the surface of the Earth. Okay, see, it is not like if one of the planet is coming and falling on the surface of the Earth. है ना? All the planets are kept in a particular order. They all are orbiting in a particular order. Why it is? It is only because of the gravitational force. Okay, so it is the gravitational force only which is assembling all the planets, stars, and galaxies in a proper manner. Okay, I'll make you right, Simon. I'll make you right. Okay, so
Okay.
all the gravitational force is assembling all the planets, stars, and galaxies in a proper order. Okay, now Ayush was asking me that, ma'am, we are putting up a vector sign over here. You have already studied the basic things in your 8th and 9th standard that we are having two type of quantities. One is your vector quantity and other one is your scalar quantity. Okay, vector quantities are those quantities which are direction specified. Okay, which are acting in a particular direction. But scalar quantities are those which can act in any of the direction. Okay, which can act in any of the direction, right? So they are not direction specified. Okay, so in vector quantities, see, in scalar quantity, when we are talking about your speed, so in the similar manner, in the vector quantity, we are talking about your velocity. Okay, and when we are talking about your force, so what is force? Force is mass into acceleration. Okay, force is m into a. A is acceleration. So what is acceleration? Acceleration is velocity per unit time. Okay, so acceleration is already a vector quantity. So that is the reason when we are multiplying, this is the next topic, next part, which will be coming over here in the next chapter, dimension analysis. In that chapter, I will tell you about the quantities which are vector, which are scalar. Okay, so the basic thing you can see over here, we know that force is mass into acceleration. Acceleration is a vector quantity. So when we are multiplying up a scalar quantity with a vector quantity, so that gives up a vector quantity. So that is the reason why I am putting up a arrowhead over here. Okay. Okay, Ayush. So that is the reason why we are putting up an arrowhead over here. Yeah. Ma'am, how action and reaction are opposite? Ishant Gupta. See, beta, action and reaction are always opposite to each other. You have done this question, all these applications of the pressure in your 9th standard as well, that when we are moving forward, okay, so we are pushing up the ground in the backward direction. So that is the reason why we are able to move in the forward direction. Okay, you have studied about that why the edge of the knife is made sharp, because that is going to give more pressure. So action and reaction are always opposite to each other. Newton's third law. To every action, there is always equal and opposite reaction. Equal and opposite. Okay, equal means when we are talking about a quantity, so every quantity is having two parts. Okay, the first part is its magnitude. Okay, the first part is its magnitude and the second part is its direction. Okay, when we are talking about a scalar quantity, so in that case, the second factor is not applicable in the case of your scalar quantity. Okay, but when we are talking about your vector quantity, so in that case, magnitude and direction, both are taken. Okay, so here, when we are talking about your force, so it is a vector quantity. Okay, so in that case, magnitude, direction, both things are taken. So what does it mean? It means, suppose I am having up a force 12 Newton. Okay, suppose a force of 12 Newton is acting over here. So it will be acting in this direction and 12 Newton will be acting in this direction. That means if it is acting in the north direction, this 12 Newton will be acting in the south direction. So that means their directions are opposite to each other. Their magnitude is equal. Okay, so that is the reason I have written here action is equal to minus of reaction. Is that clear, Ishant?
Yes, ma'am.
Ishant, am I clear?
Yes, ma'am.
Okay, beta. Any other doubt, anyone? If you are having any doubt, you can write in the chat box or you can unmute yourself and ask me. Okay, so write down examples of gravitational force. Examples of gravitational force. Write down first example. It is the gravitational force. It is the gravitational force. It is the gravitational force that keeps the earth or any other planet that keeps the earth or any other planet of the solar system in its orbit around the sun. In its orbit around the sun. Second example, we remain on the surface of the earth. We remain on the surface of the earth due to the gravitational force. Due to the gravitational force between the earth and us. Due to the gravitational force between the earth and us. Third example, the various gases forming the atmosphere, of the earth are held due to the gravitational force of the earth. The gravitational force of the earth. Fourth example, the moon orbits around the earth. The moon orbits around the earth due to the gravitational force between the moon and the earth. Between the moon and the earth. Between the moon and the earth. Fifth example, tides of the ocean. Tides of the ocean. Tides of the ocean occur due to the gravitational force between the moon. Tides of the ocean occur due to the gravitational force between the moon and the ocean water. And the ocean water. Sixth example, it is the gravitational force between the earth. It is the gravitational force between the earth and the artificial satellite which keep the satellite to move around the earth, which keep the satellite to move around the earth. Okay, which will keep the satellite to move around the earth. Next point, seventh example. It is the gravitational force. It is the gravitational force which assembles it is the gravitational force which assembles all the planets, stars and galaxies. All the planets, stars and galaxies. Written, everybody?
Yes, ma'am.
Okay. Any doubt till here?
No, ma'am, no doubts.
Okay. So coming to the next type of the force, that is your second force, that is your electromagnetic force. The second type of the force is electromagnetic force. Wait, somebody is writing in the chat box. Ma'am, dentist plays towards sun. Why they maintain their orbit? They maintain their orbit because of the gravity. See, beta, all the planets of the solar system, okay, they maintain their orbit because of the gravitational pull only. Okay, that is the gravitational force which keep them holding at their particular position. It's not like that they are colliding with each other. It is all because of the gravitational force only. Yeah. So the next type of the force is electromagnetic force. So what is electromagnetic force? See, beta, it is almost similar to that of your gravitational force. Okay. So gravitational force is acting when we are taking up your two bodies. Okay. And electromagnetic, as it is clear from the name itself, this is because of the electric charges. Okay. Electromagnetic means electricity. So electricity is because of the charges. Okay. Because of the presence of the charge. So what we are taking over here, electromagnetic force is the force of attraction or repulsion between two charges, or you can say two charged bodies. Okay, two charged bodies. Okay, so electromagnetic forces are the forces which are taking place in between. These are the forces of attraction or repulsion which are acting between two charges or two charged bodies. Okay, so they are known as electromagnetic force. They are known as electromagnetic force. Okay, now when we are talking about your electromagnetic force, in this, there comes up a term that is electrostatic force. Electrostatic force. Okay, so electro means charges. Electro means charges. And static is a word which means stationary. Okay, which means stationary, or you can say at rest. So when we are talking about the force which is acting between the charges which are present at rest, that is known as your electrostatics. That is known as electrostatics. Okay. So electrostatics, let us suppose that we are having up two charges. Let us suppose that the first charge is Q1 and the second charge is Q2. Okay. Let us suppose that first charge is present at point A and the second charge is present at point B. Okay, let us suppose that the first charge is Q1 and second charge is Q2. When we are taking up these two charges, so let's say that these two charges are separated by a distance small r. They are separated by a distance small r. Okay, now, what happens over here? Now, what we say over here, the electrostatic force between the two charges. The electrostatic force between the two charges is directly proportional to the product of the charges. Okay, earlier we were taking it as the product of the masses, but now when we are talking about your charges, so it is directly proportional to the product of the charges, okay, and it is inversely proportional to the square of the distance which is present in between the two charges. Right, now, as done earlier, we are going to combine up these two equations. So it becomes F is proportional to Q1, Q2 upon R square. Okay, F is proportional to Q1, Q2 upon R square. Okay, earlier, when we removed up this proportionality sign, so we introduced up a constant over there. That constant was your universal gravitational constant. Okay, so now also we are going to introduce one constant over here. That constant is 1 upon 4 pi epsilon naught. Okay, this is not E, this is like this. Okay, this is epsilon naught, epsilon. Okay, this is called as epsilon. So 1 upon 4 pi epsilon naught is a constant and is having up a value, that is, it becomes 1 upon 4 pi epsilon naught Q1, Q2 upon R square. Okay, so where your 1 upon 4 pi epsilon naught comes out to be 9 into 10 to the power 9 Newton meter square coulomb per coulomb square. Okay, so this is a constant quantity and is having up a particular value. Okay, so this is called as, this epsilon is basically permittivity. Okay, this is permittivity. So permittivity, this will be studying in the further chapters. So this is permittivity. Okay, this naught signifies that this is free space. Okay, or we are taking it in vacuum. But when we are taking it in reference to any of the surface, then it becomes epsilon r. It will be having different value at that time. But here we are only using 1 upon 4 pi epsilon naught. 1 upon 4 pi epsilon naught is a constant, and this is having up a value as 9 into 10 to the power 9 Newton meter square per coulomb square. Okay, we will be doing numericals for this also, for this formula. Okay, so this is 9 into, this is having the value 9 into 10 to the power 9 Newton meter square per coulomb square. Okay, so everywhere where you will be using this 1 upon 4 pi epsilon naught, you just have to directly put the value 9 into 10 to the power 9 Newton meter square per coulomb square, because this is a scientifically calculated value. This is a constant value. Okay, it remains as it is. Right, now here again, when we are talking about two charges, so again two forces will be there. There will be a force which is acting on first body because of second body, and there will be a force which is acting on second body because of the first body. Okay, so both the forces which are acting on the opposite bodies, they will be equal in magnitude, but they will be opposite in direction. Again, that same thing, that to every action, we will be having a negative reaction because we are taking up the same magnitude, but the sign over here is a different one. Is that clear? It is totally related to your topic we have done previous. Any doubt? Any doubt, beta?
I'm kind of
Yes.
confused about this epsilon, but I think as we move on, I'll understand better. So I don't know.
Beta, in the next part, in the next chapter, you are using this number of times, numerous times you are going to use, because in all the numericals, this value you are going to use. Okay. There I'll tell you that what is epsilon r. When we are taking it in reference to somebody, so there its value changes. Okay. But here we are just concerned about the free space. We are just concerned about the vacuum. So when we are taking up for the vacuum, this is a constant value and its value is 9 into 10 to the power 9 Newton meter square per Coulomb square.
Yes, ma'am.
Just go through it once for 2 minutes. If any doubt is there, you can write in the chat box. No doubts?
Ma'am? Jaspreet, ma'am?
Yes, beta.
Ma'am, electrostatic force, you've written stationary and in bracket rest. So the force occurs when an object is in a stationary position and not when it's
No,
moving.
no. Force is not stationary. Just look here carefully. I'm writing electrostatic. Electrostatic means when the electro means when we are studying about the charges, and stationary means when they are at rest. So that force in which we are taking up the charges at rest, force is not at rest.
Okay.
Force so we are calculating. Okay.
When
When
charges
we are
are
taking
at rest.
See, beta, we have to take charges at rest. Why? Because if charges are not taken at rest, तो ये R की value तो change होती रहेगी. अगर charges move करते जा रहे हैं, है ना? If they are firstly they are at a separation of 2 centimeter, then they become at the separation of 5 centimeter. तो उस केस के अंदर आपका R की जो value है वो differ करेगी, right? And if R is changing, the force is directly depending upon your distance of the separation between the charges. So मैं force कैसे calculate करूंगी?
Correct.
है ना?
Ma'am, now
So while taking up your scientific considerations, we have to make certain things constant. Okay, that means हमें उनको fix रखना पड़ेगा. तो जब उसको fix रखेंगे, then only we can get a particular value of R. Okay, so that is the reason here we are studying up your electrostatic force.
Okay, so ma'am, the charges of an electrostatic force are same and the force moves, right?
बेटा charges are not same. It's not necessary कि आपका जो Q1, Q2 same होगा. देखो बेटा, there is lot of difference between your charges and force. है ना? Charges जब हम charge लेते हैं, so charge is measured in the terms of your Coulomb. Charge is measured in the term of Coulomb. Okay. And when we are talking about your force is measured in term of Newton. So charge differ हो सकता है. Q1 ये जरूरी नहीं है कि Q1 आपका 2 Coulomb है तो आपका Q2 भी 2 Coulomb होगा. It's not necessary. Q2 can be 3 Coulomb. It can be 5 Coulomb. No one is saying that both the charges are. I'm saying that forces are equal and opposite in nature.
Okay, I understood, ma'am. And ma'am, what is stationary? That I didn't know.
Stationary charges. Charges are stationary.
Okay.
Charges are basic. Stationary means they are kept at a particular fixed distance. That's it.
Okay, ma'am.
If you are made to stand 10 centimeter apart, 20 centimeter apart from your friend, okay, and you are asked to be a statue over there, You are not supposed to move from that. That means both of you are stationary. Okay, stationary means we are not moving from that place. Electrostatic charge means the charges are kept at a particular fixed distance from each other.
Got it. Thank you. ma'am.
Okay.
Yes, ma'am.
Yes, Avnish, Q is charge. Small q is charge. This is first charge. This is second charge. Q1, Q2. Any other doubt, beta? No doubt. So write it down then. Write down electrostatic forces. Electromagnetic force. Firstly, write electromagnetic force. Electromagnetic force. Write down in this. The force of attraction or repulsion. The force of attraction or repulsion let me make one thing clear, Ayush. If you want to simplify, you can only simplify. Just look here, beta, everybody. Ayush is asking that can we further simplify it? Yes, you can simplify, but you can only simplify this factor. Okay, you cannot cancel out. Suppose if he is writing, it is 2ze square. Okay, but you can't write 4 pi epsilon naught because you can't cancel that 2 and 4. Why? Because this 1 upon 4 pi epsilon naught is having a constant value. इसको नहीं हम कुछ भी करेंगे. जब आप न्यूमेरिकल सॉल्व करेंगे बेटा, तो आप इस वैल्यू को नहीं छेड़ेंगे. इस वैल्यू को आप एज इट इज रखेंगे. आपको जो भी कैलकुलेशंस करनी है वो सिर्फ आप Q1 Q2 अपॉन R स्क्वायर में करेंगे. इसको आप चेंज नहीं करेंगे. ओके, बिकॉज इसकी एक कांस्टेंट वैल्यू है. अब सपोज आई वांट टू राइट इट, तो आई विल राइट इट 9 into 10 to the power 9 Q1 Q2 अपॉन R स्क्वायर. ओके, जो भी आपको कैलकुलेशंस करनी है यू विल कैलकुलेट इन दिस ओनली. आप इस 4 को पाई को कैंसिल नहीं कर सकते. आप इसको सॉल्व नहीं कर सकते. रेस्ट आप इस वैल्यू को जितना मर्जी सिंप्लीफाई कर लीजिए. ओके, बिकॉज दिस इज अ कांस्टेंट वैल्यू. अगर आप इसको कैंसिल कर दोगे, लाइकवाइज इफ सपोज इफ आई एम हैविंग अप अ चार्ज 2 ओवर हियर, सो अगर मैं इसको 2 से कैंसिल कर दूंगी तो बेटा 1/2 पाई एप्सिलॉन नॉट की वैल्यू फिर कहां से मैं ढूंढूंगी, है ना. इट विल बी मोर डिफिकल्ट फॉर मी. तो ये तो ऐसे ही रह जाएगा. फिर ये एप्सिलॉन नॉट का क्या करेंगे हम. अंडरस्टूड आयुष? Okay, so whenever we are calculating, whenever we are simplifying, we have to keep the constant things as it is because its value is already provided to us. That value we already know, right? We can't make any change in that value. इसके अंदर हम changes कर सकते हैं. इसको करो आप जितना मर्जी simplify करो, उसमें कोई problem नहीं है, right? Yeah, so write down the force of attraction or repulsion between the force of attraction or repulsion between the two electric charges or charged bodies. Two electric charges or charged bodies is known as electromagnetic force. Is known as electromagnetic force. Full stop. Electrostatic force is the interaction between the charges at rest. Electrostatic force is the interaction between the charges at rest. At rest. Okay. At rest. Electrostatic force between the two charges. Electrostatic force between the two charges Q1 and Q2, Q1 and Q2, which are separated by a distance small r in air, which are separated by a distance small r in air, is directly proportional to the product of the magnitude of the charges, Q1 and Q2, and inversely proportional to the square of the distance between them, and inversely proportional to the square of the distance between them. Okay, draw two charges A and B, which are present at A and B, having the value Q1 and Q2 separated by a distance small r. Then F is directly proportional to Q1, Q2. It's written on the screen, I'm pointing towards it. F is directly proportional to Q1, Q2. F is directly proportional to Q1, Q2. And F is inversely proportional to R square. F is inversely proportional to R square. Therefore, F is proportional to Q1, Q2 upon R square. F is proportional to Q1, Q2 upon R square. F is equals to 1 upon 4 pi epsilon naught Q1, Q2 upon R square. F is proportional to 1 upon 4 pi epsilon naught Q1, Q2 upon R square, where 1 upon 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton meter square per coulomb square. 9 into 10 to the power 9 Newton meter square per coulomb square. Full stop. Electrostatic forces between the two charged bodies. Electrostatic forces between the two charged bodies are equal in magnitude are equal in magnitude and opposite in direction. Are equal in magnitude and opposite in direction. Paragraph change. Let F12 be the electrostatic force on charge Q1 due to charge Q2 and F21 be the electromagnetic force on charge Q2 due to charge Q1. Then F12 is equal to minus of F21. Then F12 is equal to minus of F21. Okay, line change. The force between the moving charged bodies is known as electromagnetic force.
Ma'am, can you repeat?
The force between the moving charged bodies is known as electromagnetic force. Clear till here?
Yes, ma'am.
So next topic is characteristics of electromagnetic force. Okay. So what are the characteristics of electromagnetic force? The very first characteristic is that these forces are both attractive, okay, and repulsive in nature. These forces are attractive and repulsive in nature. Okay. Second characteristic, they are long range forces. Why they are long range forces? Because they depend upon the value of small r. Okay, because they depend upon the value of small r. So that is the reason they are long range forces. The third thing, that they are your central forces. Okay, the third thing is that these forces are central forces. Okay, fourth is that they obey inverse square law. Okay, these forces obey inverse square law. Now, the next thing, Pita, your electromagnetic forces are 10 to the power 36 times, 10 to the power 36 times stronger than gravitational force. Okay, so you can think yourself that how strong they are. Okay, so they are 10 to the power 36 times stronger than the gravitational force. Okay, next is they are conservative force. Okay, conservative force means when we are doing up the total, that means the sum total of the forces in the system remains the same. Okay, there is no loss in energy during this. Okay, so they are conservative force. Right. So all these are the characteristic of your electromagnetic forces. Okay, so write down the characteristic of electromagnetic forces. Electromagnetic forces. One second, somebody is writing in the chat box. Ma'am, can you please tell what is inverse square law? Inverse square law means that when we are talking about your force, okay, so that is inversely proportional to the square of the distance in between them. This is your inverse square law, Ayush. Okay,
Okay, ma'am.
understood?
Yes, ma'am. Got it.
Okay, so the next question is from Adit. Central force. What is central force? See, beta, central force is the force. Okay. Basically, see what we are doing in this, we are taking up two charges, hai na? And those two charges are separated by a particular distance. So central force is the force that is pointing. Okay, that means the magnitude is dependent on the distance from the source. Okay, distance from the source, because it is depending upon small r. So they are central forces. That means when a force is dependent upon the distance of the separation between the two charges, that type of the force is central force. Okay, your gravitational force is also central force. Gravitational force is also obeying up your inverse square law, because in that case also we are doing force is inversely proportional to the square of the distance. In that case, when we were taking up two bodies, so in that case, we were taking the masses, right? But they were also your central forces. Okay, Adit?
Yes, ma'am.
Okay. So write down, beta, characteristics of electromagnetic force. First, it is both attractive. It is both attractive as well as repulsive in nature. It is both attractive as well as repulsive in nature. As well as repulsive in nature. Second, it is a long range force. It is a long range force, just like gravitational force. It is a long range force, just like gravitational force. Third, it is a central force. It is a central force. It is a central force. Fourth, it obeys inverse square law. It obeys inverse square law. It obeys inverse square law. Fifth, it is 10 to the power 36 times. It is 10 to the power 36 times stronger than the it is 10 to the power 36 times stronger than the gravitational force. Gravitational force. Next point, it is a conservative force. It is a conservative force. It is a conservative force. Written. Any doubt, beta?
No, ma'am.
Okay. Next is examples of your electromagnetic force. Okay. The first example is when we are talking about your electron. है ना? So electron is always orbiting around the nucleus of the atom. Okay. When we are talking about the nucleus of the atom, so the electron is always orbiting around the nucleus of the atom. That is all because of the presence of the electromagnetic force over there. Okay. Second, two or more atoms. Two or more atoms. When we are talking about two or more atoms, so two or more atoms are held together, okay, because of electromagnetic force. Because of electromagnetic force. And when two atoms are held together, they form up a molecule. Okay, so it is electromagnetic force only which is responsible for the production of the molecule. When there are two atoms, two or more atoms, those two or more atoms are combined together with the help of your electromagnetic force only. Okay. And when two or more atoms are combining with each other, they get converted up into the form of a molecule. So that means it is electromagnetic force only which is responsible for the production of the molecule. Right? Third thing, the atoms and molecules, they are forming up matter. Okay, when we are talking about your matter, so matter is all made up of your atoms and molecules. When we are talking about your matter, so it is made up of your atoms and molecules. Okay, so it is electromagnetic force only which is responsible for the production of the matter. Right? Next thing, when we are talking about your elastic forces, when we are talking about your elastic forces, so elastic forces are also electromagnetic forces. Okay. Now, when we are talking about different chemical reactions, so in different chemical reactions, there are different type of the bond formation. Okay, different type of bonds are there, single bond, double bond, okay, trivalent bond. So those different type of the bonds, they are formed only because of the electromagnetic force. Okay, now the next example you all must have observed when you are taking up a comb, okay, and you are rubbing up that comb in your dry hair, right? So that comb which is rubbed in the dry hair, that is capable of attracting small bits of paper towards itself. That is because of the electrostatic force only. Okay, right. Now, when we are talking about your force of friction, what is force of friction? When I'm taking up my two hands and I'm rubbing up my two hands against each other, so that creates up some friction over there, right? So the force of friction is the example of electromagnetic force only, right? Am I clear?
Yes, ma'am.
Any doubt till here? Any doubt till here, beta? Any doubt till here? No doubts? Okay, then write down examples of electromagnetic force. Examples of electromagnetic force. Examples of electromagnetic force. First, write down the motion of an electron around the nucleus. The motion of an electron around the nucleus of an atom. The motion of the electron around the nucleus of an atom is due to the electromagnetic force. Is due to the electromagnetic force.
Ma'am, 1 second, could you repeat from the start?
The motion of an electron around the nucleus of an atom is due to the electromagnetic force. Is due to the electromagnetic force. Second example, two or more atoms are held together. Two or more atoms are held together due to electromagnetic force. Due to electromagnetic force that forms up a molecule. That forms up a molecule. Third example, the atoms and molecules. The atoms and molecules form a matter due to the presence of electromagnetic force. Due to the presence of electromagnetic force. Fourth example, the elastic forces are also electromagnetic force. The elastic forces are also electromagnetic force. Fifth point, the bonding forces responsible for the chemical reaction. The bonding forces for the chemical reaction is electromagnetic force. Is electromagnetic force. Sixth point, the comb attracts the comb which is rubbed, write it like this, the comb which is rubbed in the dry hair, the comb which is rubbed in the dry hair attracts the small pieces of the paper, attracts the small pieces of the paper because of electrostatic force. Because of the electrostatic force. Next point, the force of friction is the example of the force of friction is the example of the force of friction is the example of electromagnetic force because the atoms of one molecule because the atoms of you write it like this because the atoms of one body because the atoms of one body because the atoms of one body are attracted by the atoms of other body are attracted by the atoms of the other body when one body moves over the other body. When one body moves over the other body. Written. Written, beta?
Yes, ma'am.
Okay. Ayush is asking, ma'am, one small doubt. Could you please tell the difference between electromagnetic and electrostatic force? See, beta, I have already told you, electrostatic forces are the forces which are acting between the electric charges which are not moving in relation to each other. Okay, which are kept constant. They are not moving in relation to each other. Whereas when we are talking about your electromagnetic force, they are describing the interaction that take place due to the exchange of the photons. Okay, electromagnetic force includes electrostatic force. When we are talking about your electromagnetic force, so it is including up the electrostatic force inside it. But when we are talking about your electrostatic force, so it is not including up the electromagnetic force inside it. Electrostatic means charges at rest. When we are studying about the charges at rest, that comes under your electrostatic force. Electromagnetic force means the charges may move. But when we are talking about electromagnetic force, so inside electromagnetic force, electrostatic force is already contained inside it. Am I clear, Ayush?
So it's just basically the movement in relation to each other. Which
Yes,
differ.
yes.
Okay.
When they are moving in relation to each other, so that is your electromagnetic force. But when they are kept constant in relation to each other, that means their distance is not varying. That comes under the category of your electrostatic force.
Okay, ma'am, got it.
Any other doubt, anybody? Ma'am, what is conservative force? Conservative force means better law of conservation is our next topic. What are conservative force? When we are talking about a system, okay, when the sum total of the forces in that system remains constant, okay. For example, if you are having 4 toffees with you, okay, and you are giving 2 toffees to one of your friend, right? So that means you are just interchanging up the toffees, you are interchanging up the candies, but the total number of the candies remains the same unless until you are eating it. Okay, so that means the number of the toffees you have is conserved. Conserved means the total amount of the force remains conserved. That means it is only the energy. When we are talking about energy, that is only transferred from one body to another body. but the sum total of the energy remains conserved. That means there is no loss of energy. So that is your conservative force. Okay. Right. I think Venkatesh is writing this. Venkatesh, am I clear?
Yes, ma'am.
Okay. Law of conservation is our next topic. बेटा वहां पे मैं ज्यादा अच्छे से आपको explain कर पाऊंगी. Do one thing, whatever we have done, just go through it once. If any doubt is there, just ask me. If any doubt is there, ask me, beta. You can go through the previous topics also. If any doubt is there, ask me right now. Please ask, beta, whatever doubts you are having, ask me. I think those who typed in the chat box, I have answered to all the questions. If I have not missed anyone, let me check. Conservative force. Adit, any doubt? Arjun, Avnish, Ayush, any doubt, beta?
No doubts, ma'am.
Jyoti, Shreya, Siman, Vaishnav, any doubt, beta?
No, ma'am.
No doubts, ma'am.
So that means everything is clear. Huh? I want to start up with the next topic, but I won't be able to finish it in the 3 minutes. That is nuclear forces, strong and weak nuclear forces. I won't be able to cover them up in the next topic. So let me give you up a brief idea about what are nuclear forces. See, beta, nuclear forces means the forces. There is somebody in the chat box. Let me see. Something related. So electromagnetic force, but in chemistry, potential energy of the two charged particles Q1. Potential energy. One second. Beta, can you please speak out and tell me? Because half of the
Yes,
portion
ma'am.
is visible over here. Yeah, please tell me what doubt are you having? Tell me, I will clear it.
Okay, ma'am. So now we studied like in the previous topic, which is electromagnetic force. We studied the distance. The electromagnetic force between two particles is a charge of the product of the charge of two particles divided by the square of the distance between them.
You can't write it equal. one thing.
Yes,
It
ma'am.
is
It-
1 upon
the
4 pi
permittivity
epsilon naught will
factor.
be there. Yeah.
Yes, into the
Hmm.
permittivity factor. But then the same
Yes.
thing we studied in chemistry also.
Huh.
So in that they told us about the potential energy. So potential energy of two charged particles is equal to one the permittivity factor into the product of the charge of two particles divided by just the radius. Why isn't it radius square? I mean the distance square over there. I didn't get that
Potential
part.
energy. Potential. You are asking about the potential energy of two charged particles,
Yes, ma'am.
right?
So is it like different topics or is it something related?
It is different topic, Peter. Potential energy, when we are talking about the potential energy of the two charged particles now, so in that case we are talking about two like charges, that means two protons or two electrons, so they are brought towards each other. Okay, so when two electrons, two protons, they are brought towards each other, you are understanding the thing. Here I am talking about the two charges which are kept at a certain distance, which are kept
Yes,
at a
ma'am.
particular distance. Okay, in that case that distance is decreased, they are brought in contact with each other.
Okay. Yes, ma'am.
Okay, understood the thing? They are brought in contact with each other. So that is the reason we are not taking. Why we are taking R square? Because once we are going from first to second particle and then we are coming from second to first particle. So the distance becomes square in that case. Right?
Okay, ma'am.
But
Yes.
that in the case of chemistry, when you are talking about the potential energy of the two charged particles, in that case we are taking two charged particles which are like in nature. I have not told you anything like this in this particular topic, that when we are taking up two charges, so they must be your similar charges, hai na? So I am not told anything like that. But in that case, the two charges which are taken are similar in nature. They are like charges.
Yes,
Okay.
ma'am.
So the potential energy of the system in that case increases. That increases. Okay. So the basically general formula which we are using over there is now voltage is equal to energy upon charge. But actually that is a different topic.
Okay,
Okay.
ma'am. Yes, ma'am.
Don't get confused in between them. That is just a totally different topic.
Okay, ma'am.
Okay.
Got it.
So basically in that we are taking the electric constant K. That is not dielectric constant. That is just electric constant K. It is multiplied by one of the charges and then multiplied by the other charge. And then we divide by the distance between those two charges. It is not square of the distance between those two charges. Okay.
Yes, ma'am. Got it.
Okay. Any other doubt, Beta? Anyone? No doubts? Okay, so before next class, Pitam, just read out the topics, whatever you have written in the notes. Also, go through your textbook also, right? From your NCERT textbook. So go through all these topics from your book as well. If any doubt is there, just mark it there and then only. In the next class, for the first 10 minutes, I can take your doubts. If you are having any doubt from the book as well, you can tell me the page number. I'll clear your doubts from there also. Right? Is that okay, beta?
Yes, ma'am.